This video is about looking at independence from a two-way table. Okay, so in mathematics, specifically in statistics, independence is where the probability of A given B is the same or very, very close to the probability of A, meaning that it doesn't matter whether or not B happened, the probability that A happened is about the same. So whether or not B happened, these probabilities are about the same. Okay, when that happens, we say that A and B are independent of each other. It doesn't matter if B happens, A has the same chance of happening. Okay, I've already filled out this two-way table. See that video if you want to look up how to do that. I also have these conditional probabilities already filled out from a previous video, so watch that video as well. I'm answering the question of, do you think there is a difference in how male and female voters rated the library services? Explain your answer. Well, I'm going to look at independence, okay? And I can look really at any of these, and I will pick out two just examples. But when you're asked this question, you can look at just one, and you'll have the answer either way. So I'm going to look at the probability that they rate it as good, this first one right here, good, given that they're male, and ask the question, is that the same or very close to the chance that they rate it as good? Okay, so it doesn't matter if they're male or not. Would they have the same chance of rating it as good? Well, I've already figured this out. Good given male is 0.378. Is that the same that they rate it good? Well, let's see here. Out of all of my voters, I have 184 that rate it as good out of a total of 515 voters. Okay, if I divide 184 divided by 515, then I get the number 0.357. So I ask you the question of, is 0.378 close to 0.357? Okay, now this, in a lot of things in statistics, it's not like black and white. It's not like, oh, this is obviously yes or no. Are these numbers close together? And along with that, out of 515 voters, right? Are these numbers close together? Well, they kind of are. They're only like 200ths apart, right? And so that might lead me to believe that rating it good and being male are independent. That rating the library as good is independent of gender. Okay, so it's kind of a do you think answer, and so I might say no. That it seems that library rating and gender are independent because the probability of good given male, I'm sorry this is so small, is similar to the probability of good. Okay, so that's so small. Okay, let me show you this from a different direction, a different one, and you can test just one of these and not have to do multiple ones. Okay, I'm going to pick this down here just because it's different. The probability of female given good, is that the same or very close to the probability of, again, it's the first one, probability of female. Meaning, if they rated the chance that they're female, whether or not they rated the service as good. Well, I've already figured out female given good is 0.505. Okay, what's the chance from this survey that they're female? Well, if I look up here, I have 274 females out of the 515 that responded to the survey. And if I divide 274 divided by 515, then I get 0.53. Okay, now is 0.505 similar to 0.53 out of a survey of 515 people? Yeah, that's kind of close. So again, you might say that these are close together, and so they might be. Okay, and this will be addressed in much more rigor if you take AP statistics or a college level stats class. But at least for now, we're looking to see is the probability of A given B somewhat close to the probability of given A? And in this case, it looks like gender and library rating seem like they might be independent.